se a ferragem das vigas da sua obra estiver no meio, você está jogando dinheiro fora. Isso porque nas vigas, as barras de reforço ou elas estão na parte de baixo, quando a viga está em 2 apoios, ou elas estão na parte de cima, quando a viga está em balanço. E que quando você coloca uma barra de reforço no meio, ela está no que nós chamamos na linha neutra, ou seja, ela não trabalha nem na compressão nem na tração. Em outras palavras, você jogou o valor dessa barra fora, ela não está ficando errada. Agora a circunstância muda com o pilar. Então se a gente vira e usa essa barra no meio para um pilar, aí sim, ela funciona show de bola. Então agora você já sabe, sempre que você ver uma viga com a barra no meio, você lembra, esse aí levou prejuízo dos grandes. E para mais dicas de obra e construção, segue nesse kit de engenharia e design.
So okay, I don't know if you heard what the man was saying in the video, but I guess the answer is no. You and I didn't hear what the man said in that video, but I can help to tell you some important things that he was trying to say in that video that will help you to save your materials instead of wasting them during construction work. So let us proceed. Here now, this beam reinforcement that I just highlighted now is a beam reinforcement just like that one that he was using. Let me use this one as an illustration to make everything clear to you. So now we have 6 rubbers. We have 6 bars in this beam reinforcement. We have 1, 2, 3, 4, 5, and 6. Then at the top we have the reinforcement at the compression zone of this beam if it's simply reinforced, if it's simply supported. So, and at the bottom we have the tension reinforcement, which is the set of reinforcement doing the most work in this beam reinforcement, as you are seeing. Then at the center we have another set of rubbers, which is this and these two that I highlighted now, which is that too. But in this video now, the essence is to let you know that these 2 reinforcements here are waste of material. What the man was also telling you in that video is that these 2 reinforcements, these 2 rubbers here, are waste of materials. In a beam design, you don't have to put reinforcement, you don't have to put any rubber at that center, because as you can see, I wrote something. I have other the illustrations here that I will use to explain things better for your understanding, but let us focus on this one first. So as you can see here, I have a written word said NA. NA simply means neutral axis. Neutral axis is a 9 in a beam when the bending stress is equal to 0. That is here now. Here in this red line that I drew here, there is no force, there is no reaction taking place within here. So as there is no reaction taking place in this area of this cross section of this beam now, that means there is no need for you to put reinforcement, there is no need for you to put rubbers at that center. Hence the man was telling you in that video that these 2 reinforcements here are total waste of material, and he is right. So let us proceed. Instead of your beam looking like this, it is better is this way, because these extra 2 at the center here are doing no work. It's better this way than this way, it is better like this. Or if your beam design requires that the rubbers, the bars in your beam should be up to 6, it should be now this way. After that, you have put your tension reinforcement, which are these 2 here. Then you should give like 2 or 1 inch space, then put the rest 2 at the top. Put them at the top, or rather you can still put them in between these 2 instead of putting them at this NA center at this red line that I drew here. If you put them there, it's just a waste of material. It's doing no work. And then this one at the top, as I've told you, is hanger. They are just working as hanger. They are at the compression zone of this beam reinforcement, and then the concrete will take care of the compression. So they are just working as hangers, beam hangers. Then as we proceed, okay, so just as we proceed, this is for simply supported beams, but let us look at cantilever beam. When the beam is cantilevered, if the beam is cantilevered, you will see something like this. If it's cantilevered, you will see something like this and not like this. You will not see, if something like this doesn't make any sense. Something like this one doesn't make any sense. If the beam is cantilevered, it and requires that you should put like 6 bars on it. So that means now this the top of this beam reinforcement has now automatically become the tension reinforcement, while the bottom here become the compression reinforcement. So now more reinforcements are required at this top. That is why you should put 4 at the top. When the beam requires 6 bars, then you put 4 at the top here to serve as the tension reinforcements, not at the center. If you bring this end down here, if you bring these two down here, these two have automatically turned to waste material, because here is the neutral axis. Neutral axis, just as I've said, is a 9 in the beam where the bending stress is equals to 0. Or rather, when your beam design requires, let me say, up to 8 bars. As you can see, we have up to 9 bars or more, or 8, anything at all. When it requires that kind number of reinforcement due to the design, is either you go this way, you have to put higher number of the reinforcement at the top for the cantilever beam, not for simply supported beam. When I say simply supported beam, those who know what I mean by simply supported beam are beam that has pina, that has cono at the 2 ending of it. Then now for the cantilever just have a pina at one side, while the other one is hanging. So now for the hanger beams, the reinforcements have to be this way or this way, not this way. Any bars that you put within here is a waste of material. It's better you just put them down and use them for another thing than to put them here. Okay, I don't know if now you can now understand what the man was trying to explain in the video. I know that at least you know what NA means, and then you have to avoid putting your reinforcement at the center, thereby wasting your materials. And then I know that you also have not something like how the design of your cantilever and simply supported beam should look more like. Okay, now thank you for your time and watching the video.